Greetings and welcome to another Reimblock screencast. In this screencast, we're going to continue our journey in YAWL, and we will now look at how YAWL handles mappings. So let's get straight to it. Over here in this editor, I've got the same YAWL storage complex contract that we were looking at in the previous video. And here I've added some mappings. So I've got three types of mappings here, a so-called simple mapping, which is just a mapping from uint 256 to 256, a mapping of uint 256 to a mapping of uint 256 to uint 56. So this is basically a nested mapping. And then an address to a list or an address to an array of uint 256 values. Now in the constructor, I've set these mappings as you can see here. So the simple mapping is like this, the nested mapping is like this, and the address to list mapping looks like this. So what I'm going to do now is deploy the contract, and we're going to interact with these mappings using YAWL. So the first thing I want to show you is how we can get a value from a simple mapping like this one here, from simple mapping. So I've got a function here called getMappingValue, and as you can see, it takes a key. So if we look at the simple mapping, we can see the key, we've got two keys. We've got key 88, which will return a value of 1, and key 99 will return a value of 2. So if we wanted to get the value of key 88 back, we would pass in 88 into here. And what we would do with that key is essentially we would Keccak 256 that together with the slot of the mapping. And that will give us the data location. So as you can see, its behavior and structure is very similar to how a dynamic array works, in the sense that you initially take you get the slot of the data that you're interested in this case the slot where simple mapping is stored, and then you Keccak 256 that with the key that you're interested in, and that gives you the location of the data, which you can then just load using sload. So let's call that function just to make sure that this is working. So the function is called getMappingValue, this one here. So we just try that with index 0, and we get back, sorry, it's not indexes, it's keys. So key 0, 88 gives us 1, and key 99 will give us 2. So that gave us these two values here. So that's how we can read values from a simple mapping in YAWL using this approach here. Now the next one is nested mapping. So let's take a look at that. So this is reading the value from the nested mapping that we have got set up. And of course, in a nested mapping scenario, you need to get two keys passed in. So we've got the value, the function here, and we can take a look at that. So let's take a look at the nested mapping. We've got 9 and 8. So let's pass that in. 9 and 8 are the two keys, and it gives us 7. And 99, 88 gives us 77. So the function is working. How does it work? Well, it's very similar. It takes the slot where the nested mapping is located, and it will combine that with the key, the first key, and Keccak 256 that to give you a value, which will then be combined with key 2, and then that whole thing is Keccak 256. It's hashed to give you the data location. So again, it's a combination of the keys and the slot to give you the data location. Notice that the keys are hashed from left to right, even though in the actual mapping it's right to left. So key 1, 9, is the leftmost key, but it is the rightmost value that is hashed, which is then combined with key 2, which is then hashed together to get the data location. So that's how we can get values out of a nested mapping using YAWL. Now the last example is the address to list mapping. And this is interesting because firstly, we're using a different key type, which is an address. In fact, we'll see that there's no difference in terms of how we get the value back using this type of key. But the interesting part, of course, is that the array is now a dynamic array. So let's take a look at this behavior. Let's break this down into two steps, in fact. So the first step is to see what does the slot return us if we take a look at it. And as you may have guessed already, or by the previous videos and by this function name, it gives us the length of the dynamic array. So let's take a look at that first. Let's call that function. This is it here, so we call that, and you can see it returns a value of 3. And if we check that, we can see that indeed it has 3 elements in the array. So why is that? Why is it returning the length? Well, it's because of the same way that arrays work, or dynamic arrays work in Solidity, is how it would work with a mapping in this case. So we Keccak256 the key with the slot, and that gives us the data location. Actually, strictly speaking, it's not the data location, it's the location of the value, which happens to be a dynamic array. And because it's a dynamic array, we know already that the first value at that slot is going to be the length of the array. So how then do we get the actual value back? So in order to get the data from the mapped array that has a key of address, we just need to call Keccak256 again on the Keccak256 of the key and the slot to give us the location of the data that we're interested in. And then we use the sload function to get the data at that location, and we pass in the index and add that to the location as an offset. So if we want index 0, then obviously it's going to get the data at that location, and index 1 will add 1 to that, and so on. So we've got this function defined here, which we can call from the console here in Remix, and we can pass in index 0 and see what value we get back. And we get back 55. Let's just scroll up quickly to see that. Let's get back index 1, 44, index 2, 33, right? So we're getting the correct values back from this array, which is mapped via this address key. So that's it. That's how we can map values in Solidity and then use Yawl to retrieve those values back out in our client. So I hope you enjoyed this video, and I'll see you in the next.